Well, good afternoon, everyone. Welcome to Church Facility Management Solutions. Today's episode, or this month's episode, is on HVAC control systems. A little bit of housekeeping before we go through. Keep in mind that if you have questions, feel free to submit them via the question pane. We will do our best to answer them as soon as possible, work it into the conversation. Some of them we'll try to answer without, if we can. As we go through, keep in mind our email address. You can always email us with additional questions at cfms@coolsolutionsgroup.com. That's cfms@coolsolutionsgroup.com. I want to thank you for joining us today. Today you will be hearing from me. Again, my name is Nathan Parr. I'm a facility specialist at Cool Solutions Group. I also currently handle and the company side of HVAC integrations. So if you've ever called or had some questions about how to integrate your control system or maybe change control system, you probably talked to me and hopefully you've got an answer that has helped you out. In this webinar and for this webinar, we're not going to go down deep into the weeds of all the different control systems and how to actually do programming and things like that. This webinar is designed simply to go over some of the basics, define some of these terms, talk about some scheduling strategies and ways to save and return on investment and some necessary knowledge you have as you consider, is it time to change out my control systems? If you've been on these webinars before, especially if you saw the one on energy management, we know that controlling and taking better control over HVAC will save us money. That has been shown time and again. It is proven. The only folks who don't save money when they get better control of their HVAC are those who don't use it to its advantage. So hopefully today we'll get some good groundwork, some base knowledge laid, and then we can take it further as we go along. So again, send those questions in as you have them. And I do have in the available handouts, if you see it there on your control panel, you'll see the slide deck. It is there on your handouts ready if you'd like to download that for yourself. So let me just jump right into it and we'll talk about the things that we're going to discuss today. So again, we're going to talk 4 different areas. First, we're going to talk about terms, and we're going to define some common terms and controls. We're not going to go over every term in HVAC because that's a lot, but we'll talk about specific terms that we use and you might hear that you need to make sure that you understand and are tracking. We're going to talk a little bit about types of controls, and I've divided it into 4 categories. This is my preference. It's the way I've done it, but for our discussion, that's what we're going to do. We're going to talk a little bit about scheduling strategies, and again, effectively scheduling your system is where you gain the most return. And then we're going to talk about other ways to save, mention again, return on investment and some necessary knowledge. This is stuff that you will need if you want to definitely have an effective control and HVAC control system. So terms. Now, I'm not going to read word for word all of these different terms, and I can hear everybody saying, thank you for not reading it. We can do it ourselves. But I just want to talk, I've pulled out some common ones that I get questions on and that I'll use, and sometimes people don't realize what I'm talking about, so that's why they're out here. So the first one, air handling unit. Basically, that's going to be your inside a piece of equipment. It's going to be the one that you're hot or cold, either water or coils or electric heat, all that stuff. It's going to be housed in, and it's going to have that blower motor, and it's creating that airflow, goes across that heated or cooled coil and sends it out into your ductwork. So that's our air handling unit. It does not include all of the different stuff and the other components, but that's your main equipment. So when you're doing your PMs typically, and I hope everybody is doing PMs, your air handling unit is where you're changing your filters for most people and most things. BACnet. When I start talking BACnet, it can sound like a different language, a foreign language. Well, it is a language. It is a programming language. It is designed to be universal, meaning that anyone who designs or has a piece of equipment or component that is, quote, BACnet compatible, it means they theoretically can talk to each other. I say theoretically and I say supposed to. Just because it's BACnet does not mean it's going to communicate well. But if it is BACnet or it will accept BACnet inputs, that is better than proprietary systems. So if you're speccing systems, that's a great question to ask. What language does it speak, and can it play nice with others? Now, some of these, the BAS, BEMS, and BMS, they all sound the same and they frequently get used interchangeably. However, when we talk about a BAS, a building automation system, we're talking about already installed and automatic control systems that aren't necessarily influenced or need to be influenced by us. Just like it says, it's automatic. So fire suppression and fire alarm systems are great examples. You don't have to do things when the fire alarm goes off. It automatically starts closing doors and shutting things off. That's a building automation system, an example of one. A BEMS, or building energy management system, now we're monitoring energy. So now we're looking at panels, then electrical, how much electricity are we drawing? Do we have a hot leg or things like that? So we're collecting information, we're collecting data, and through that data then we're able to make changes within and how we operate our system. And so that's what BEMS is, building energy management. A building management system is how we actually manage the stuff, a central area. Now, this doesn't always have to be real fancy. It doesn't always have to be completely together. It can be cobbled together by multiple systems. It's just we've put it all together so that we can somehow remotely impact all of our different systems within our facility. Dampers, that comes into play, but understand a damper is something that allows you to limit, open up or limit airflow through a duct typically, or an inlet. That really is important when it comes to talking about outside air, and we'll get into that a little bit later, but just know that's what a damper is. It also impacts, I didn't talk about in the terms, but if we test and balance our system and we're looking at a test and balancing, that's why we have dampers in all of these different ducts and runs, because a properly balanced system is giving you the proper amount of air through each outlet in each area. And if you are unsure what I'm talking about from a test and balance, or what that is, or if you think I've never heard of that before, never had it done, I would encourage you to explore getting that done in your facility. A properly balanced system is more efficient and will lead to better perceived comfort within your facility. Deadband or dead zone. This is something that I see a lot and we talk about a lot. I've highlighted a certain section of it. You see the bolded section. The purpose is common to prevent oscillation or repeated activation, deactivation cycles. So when we're talking about deadband, typically your heating set point and your cooling set point, that creates a deadband, the distance between those two set points. The farther they are, it creates a greater opportunity for your equipment not to be energized. It's a fancy way of saying you can save money if you have a larger deadband. So if you're setting your system at 70 heat and 72 cool, you've pretty much negated any deadband in there, and so your system is constantly going to be energizing one way or the other, or thinking it needs to, potentially. If the system is always thinking it needs to run, that means it's always energized, which means you're always spending money. So rather than doing a 70 to 72, if your comfort set point is 70 degrees, consider putting your heating set point at about 66, 67, and your cooling set point at about 71, 72. That'll keep it within that range, just below 72 and just above 68 generally. Many thermostats have built-in deadbands that they'll modulate in between 2 to 4 degrees. So just understand, scheduling them close doesn't necessarily mean that you're going to keep that constant temperature constant. If you need to do that, so for example, in a server room, if you need to accomplish that, there's different ways and there's different controls that we would use to make sure that we have a constant temperature. Direct digital controls. It's just a term that means it's a digital controls, okay? And it's more advanced. It's coming in within our network. We can get different inputs from all over the building, and then based on the logic that we've put in, it'll make decisions. An EMS, we talked about a building, now we're talking about an energy management system. So it's just basically, it's very similar. It's controls, software, it's monitoring, and it's optimizing, and that's the key. It's optimizing the use of energy in commercial buildings. So we're looking at the meters, we're looking at the panels, not just the equipment. Is it running or is it not running? We're looking at what's the draw. Keep in mind, and we talked about this in the energy management webinar, things plugged in, even if you're not actively using it, if it's still plugged into the outlet, it's still potentially drawing energy. And you can actually use energy management and different monitors to start checking out your facility, finding out where you've got draws and energy that you're using that you may not be aware of. The more that we get rid of that, again, the more money we save. Gateways, as we start bringing in Wi-Fi stats, if we start bringing in smart building controls, as we start bringing in all this digital stuff, you need to make sure that we've got a way to make sure all the different systems can communicate. Many times you may have to look at installing a gateway to provide that bridge between different systems. Some of them can be set there on your server or set there on your internal network, and that's great, but sometimes you've got to provide a gateway to translate between one version or one input programming type language to another. Lawn Talk is similar to BACnet in that it is a standardized programming and communication protocol. You see it a lot when they've expanded to controls over different types of systems, HVAC, lighting, things like that, home automation. And again, that's just, in essence, think of it as a language. Now, if you've done anything with a robust control system, you've probably heard the term JACE, J-A-C-E. It sounds exotic, but really it's a box. It's a mechanism, and within it is certain programming, and then it allows it devices to do things that you tell it to do within a Niagara framework. And so then the question becomes, what's a Niagara framework? Well, we've got both N4 and AX, and it's a universal software language infrastructure that certified folks can use and create custom solutions. So if you've gone with and talked to a company that has good Niagara certified programmers, and that's important when we're talking about Niagara and certain things, it's important to make sure that you've got a controls contractor who has an actual certified person to do that work. What we find is many times a company will sell, an HVAC company will say, yes, we can do control systems, and they'll sell a branded control system, but they don't have a certified controller on staff. Everything's great as long as the system doesn't experience any issues or you don't try to make any customization to it. When you start doing that, if they don't have a certified controls person, a certified programmer, you're unable to do the things that you might need to do, and it's very difficult to get troubleshooting done if they're not good and certified on that. So look for that. So Niagara and JACE, that's a very common, you'll hear that a lot. N4 and AX is just two different protocols within the Niagara framework. Programmable thermostat, it's pretty straightforward, we know that. But, and it can be programmed either at the thermostat or hopefully integrated within some type of scheduling software. Sensor is important. There's lots of different types of sensors. But many times as you're building, and we're going to talk about building a simple logic or a simple building control system through off-the-shelf products. If you're doing that, what you're going to find is there are so many sensors available that allow you to track certain things, and you can build a very robust system. We can track temperatures and water flow and electricity and all sorts of things. And it's just a matter of finding something that was compatible with the control system that you're using. And software, it's pretty straightforward software. It's just like it sounds. It's what we put on the computer. The thing to remember about software and to ask when you're talking to a company that's installing a control system is, how often is it updated? And what happens when it's updated. Is it backwards compatible? If we've got certain things that are in it, if I update the software, we've seen it with Windows several times. You'll get a Windows update, and then a program you were using is no longer able to work because it hasn't been updated for the new Windows update. Same thing can happen with building control systems. When that does, it is very difficult and it's much more expensive to get a workaround because you have to do it quick. So ask those questions on software. How often is it going to be backwards compatible? Make sure that they've got some pretty good answers on that. Thermostat or a stat, that's what we're using to control the system. And the last thing, variable air volume system. Some systems have this, and we talk about VAVs, and that's where we're controlling those dampers, an automated actuator or something like that, to determine how much air is going to all the different areas of our building. If you have VAVs, hopefully you've done some homework and you've are really monitoring those and understand them completely. If not, let me know. I've got some great research material on it. VAVs are very effective if you've got a larger unit, but you connected to a whole series of rooms. Rather than having to cool every room, if you've got VAVs, we can start directing the airflow where it's needed. And once we direct it where it's needed, then we're not cooling and heating spaces that we don't have to. So those are some common terms that we talk about a lot in controls and when we're talking that. So types of controls. Today is a series of 4s. I've broken it again up into a series of 4. So we're talking about some standalone thermostats first. Many of you, unfortunately, may be familiar with especially that round dial there on the upper right. Obviously, when I talk about standalone thermostats, we're talking about those old school traditional thermostats. Many of them, some of them may even have mercury bulbs here. That's what we're using. I may be showing my age as I start talking about that, but the round dials and the mercury bulb stuff. You'll see them, and as we consider them, you know, they can be dial, digital, programmable, or non-programmable. It just depends. Slides, not very accurate. They're not connected, and by connected, obviously we mean they're not connected to some sort of control system, some sort of network. And so that means you always have to go to them to see what they're doing and to see what's been done to them. Many times, until we were able to start locking out with some of our other types of units, you would put the lockbox on the wall so people could mess with the thermostat. But everybody knows if you get a pencil, if you get a ruler, you can manipulate, stick it through the air holes and adjust the thermostat anyway. So you've got to always go look at them to see who did what. Did they turn it off, turn it up, turn it down? So locking out, again, you can always bypass it. It frequently happens, and it doesn't collect data, trends. We don't know who touched it. We don't know when they touched it. We don't know how long it's been running. They are cheap and available, though. You can go to almost any home store, not just the big box stores, but any hardware store, any thing that sells home stuff, and you can probably find a thermostat that you can slap on the wall. Obviously, the least efficient, and probably the ones, if you have them in your building, you're on this webinar because you really want to know what you can do to get rid of them. So the next step up are connected, or what we commonly refer to as Wi-Fi thermostats. Now, I do want to point out here, Wi-Fi is a term we throw out, but it's not universal with how some of these thermostats connect. For example, Pelican and network thermostats create what they call an internal or strong mesh network. So they're connected stats, but the thermostats and the devices themselves communicate with each other on a self-generating and self-supporting network, and they report back to a piece of equipment that then connects into your network and then goes from there. So a connected or Wi-Fi, that doesn't necessarily mean it's on your network, but we just kind of use that as a general term. So make sure you understand what kind of thermostat you're looking at. Is it a internal generating mesh network, or is it a true Wi-Fi thermostat, meaning you need to have a robust Wi-Fi network? So when we look at them, they're all going to be digital for the most part and programmable. In addition to programmable at the stat, Wi-Fi stats, part of the draw is they're generally configurable on a secondary device or a computer. You can generally effectively limit access, not just by putting a lockbox on the wall, but you can actually program them to not allow access. Many of them allow you to lock out most of the features, except for somebody wants to come up to it and bump it up or down a couple degrees. You can give them that allow access, and then after a couple hours, it reverts back to whatever you wanted it programmed to. This is where we start collecting data, and we see data collected. So even the homeowner brand ones like the EcoBees and the things that you go to the home stores and buy that are Wi-Fi, they're also collecting trends and collecting data. Data is king. Data is great. I hope you're using data. We'll talk about that just a little bit later as well. These stats are available pretty much anywhere, but they're not cheap. Obviously, the standalone stats are, you can pick one up for 20, 30, 40 bucks. A good Wi-Fi stat that's going to be able to control pretty much any of your equipment, of your normal equipment, you're looking at starting at around 250 bucks on up. That's just the nature of what it is. With these, depending on the brand, we also start to expand what we can monitor and or control. And so keep in mind, some of these stats, if you dig a little deeper, you start to see that they might have additional inputs. Some of them have multiple inputs, and they can look at your supply air temp. We can maybe control some things that have dry contacts with this stat. We can even start controlling VAVs and turn things on and off through IO, simple input in, input out devices, all through a stat. And so it's a way then to create a more robust integrated system, which brings us to this next slide. So we talk about these simple integrated control systems. So when we talk about that, we're talking about systems that you can create and put together in-house. So we're talking about off-the-shelf components. There may be some programming that needs to happen, but for the most part, if you're doing a simple integrated control system, you can put it together. It takes time and research and then patience. So, but we can get the components. We're able to monitor much more than just set points and schedules. Again, we're taking control of more things. We're gathering much more data. It is a more complex install because now we've got to communicate and make sure stuff is wired back where it needs to go, that it's programmed within some sort of user interface so that we know what's monitoring what. And depending on what we're monitoring is going to really inform the costs. But now we're able to look at VAVs, even more, water freezer, even refrigerator temps, flow rates. We can track how much water is flowing. So if we want to see if a pipe burst, for example, if you're in an area that is prone to freezing, we can get a system and create it to where it monitors if water bursts a pipe and pipe starts running everywhere. Energy uses at the panel. InTouch, for example, has an energy monitoring component where we can put a device to monitor each leg on a system coming in, incoming building power, and then start monitoring up to 8 different circuits. And so we can actually find out how much energy we're drawing in all these places. You can put multiples of those within a facility. So again, we can start getting, I say simple, we can start getting a really complex integrated control system. The main thing is these are not generally customizable in the programming. It does what it does. It'll collect the data that it's going to collect, but you're not going to write additional logic on top of this type of control system. When we start talking about logic, that's when we jump into these complex integrated control systems. These are the ones that, again, it's going to take a programmer. It's going to take someone who really knows what they're doing to make sure they get the logic in the way it should be and it's done correctly. The cost, it's just gone way up. It's not uncommon to see $30, $40, $60, $80,000 estimates for a basic complex integrated control system. It does require, as I said, qualified installer and programmer, because it's not just plugging in all of the devices, the valves, and everything that you want to control. It's also writing the logic to make sure it does that and does what it's supposed to do the way it's supposed to do it. It also is going to require some dedicated IT resources within your facility. as well as potentially dedicated power and power supplies and additional backup stuff, because as we increase the complexity with our control system, what happens is we become more dependent on it. And so when we experience a catastrophic power loss or some type of failure, it will have a much greater effect on operations than when we are using simple controls. So just keep that in mind. And with this complex integrated control system, now we can pretty much do anything we've got the money for. I'll give you a very recent example. I met with one of our subscriber churches the other day, and they had a great Johnson Medisys system, and they were able to take that system and integrate some additional lighting and access controls and safety protocols within that system, just by simply adding in some input-output devices and writing some programming language that says, this is what I want you to do, and that's what I need you to do. So you can get a great deal of stuff done through there and with that system. So those are the four types of four categories that I put those systems in. Remember, if there's any questions as we go along, please just ask that question in the question pane and I'll get to them. So from the control systems, all of these, with the exception of the non-programmable stats. Okay, yes, you can do some things with that, but it's going to require somebody doing it, so it's not very effective. So let's throw that out there. So for the three, let's talk about effective scheduling strategies. I've got there 3 different types of schedules, and part of the discussion, keep in mind too, is our what Energy Star recommends and what we've learned from our energy efficiency stuff. The larger difference in set points, the greater difference means the greater potential for savings. So when we think of our schedules, I like to think of it in 3 types. Unoccupied. Unoccupied is when I have nobody in the building, nobody's in there. I let that go. Get the coldest I'm going to let it get. I let it to get the hottest that I'm going to let it to get. Okay, I don't need anything going on in the building. I don't need anything running. My next level of schedule then is my occupied or open schedule. So this is when people might be coming into the building, but I don't necessarily have any events. So I might be taking the edge off one way or the other of the temperature, but I'm certainly not making it to where someone's super comfortable there like they would be for a Bible study or something like that. So I'm kind of bringing a setback. Then I've got my comfort event setting, and that's when I'm bringing the temperature to the area that I want it to keep somebody comfortable all day long. That's going to be my most coolest or warmest set point generally for that. So again, Energy Star, a minimum 8-degree difference to see the most savings. So they're saying if you have 72 as your cooling set point, to get the most and start getting the most of your savings, when you do a setback or a night setback, you need to punch it up to 80. You do that, you're going to see a lot of savings. Now with churches and with throughout the day, we've got multiple events happening at different times, different things going on. That's when, and that's why we recommend having that occupied, which is interim, kind of in between the unoccupied and the comfort event setting, because it's easier and quicker to get a room down to set point if it's 4 degrees warmer or cooler than your setback. And that's why we say bring the occupied to within 3 to 5 degrees of your desired event setting. And then that allows you to take advantage of that lockout feature that many thermostats feature, which is allowing anybody to come in if they forgot to schedule the room. I know that happens very, very seldom in the church world. Everybody is always good about getting everything on the calendar. However, for that time that it happens that they don't get it on the calendar, if we've got our occupied setting within 3 to 5 degrees and we allow them 4-degree adjustment, they can go into the room and they can hit that thermostat, and for 1 or 2 hours they can adjust that temperature themselves. And then after 2 hours, 1 to 2 hours, depending on how long we let them do it, it reverts back to our more efficient settings. And so we no longer have that, gee, somebody put it down to 68 and forgot to put it back when they left, and we've been cooling that space for the last 3 days at 68. So, and then watch your heating cool settings. Remember that deadband we talked about earlier. If you put it too close, you're not keeping it rigid on that set point. You're just hurting your equipment. It's designed to have, and if you look at the graph, you'll see your set point, and you should see a sine wave. And that's normal, and that's what you're looking for, and that's what it's designed for. So ways to save, return on investment, and some necessary knowledge. Okay. A biggie, a real big one, is demand control ventilation. We talked about the dampers and the actuators a little bit in a system. And keep in mind, you can put in a demand control ventilation system that is independent of everything else. Okay, so when we talk about demand control ventilation and what we're talking, your system was designed with max capacity in mind. And that means it also was designed to have the most fresh air that would be required when you're fully occupied to get the proper fresh air exchange and to make sure our CO2 levels don't go up too high. Most of us are not operating at full capacity day in, day out. Because of that, we can take a look at our CO2 or our demand control ventilation, our outside air, how much we're bringing in. A lot of time you can monitor that through CO2 sensors. And we can say, as long as the level of CO2, and we can monitor it in all of the most occupied spaces, that's where it's always recommended, put those CO2 sensors where you're most occupied. And as long as it doesn't exceed the 1,000 parts per million, which is a general rule, then don't bring in outside air, because what is outside air? It's unconditioned air. So now, if it's 100 degrees outside and you're trying to cool to 72, bringing in 100% of the volume of outside air that the system is designed for means you're trying to cool this 100-degree air down to 72, rather than cooling your building air of 78 down to 72. If we're able to limit the outside air to only bring it in when we need it, our equipment can operate that much more efficiently, and it saves us money, quite a bit of money. And it also will keep, especially if you're in a humid region, we're not bringing in that humid air. It makes your building feel cooler, feel better. As always, check your local guidelines to make sure your codes allow it. But again, most places can do that, and you can set it independent of your other system. Again, it just takes monitoring the CO2 levels in your main occupied spaces. And if at some point you want a nice, easy 60-page read on demand control ventilation, let me know, because I have one. It's a great engineering document, but it really explains it and some of the advantages of that. Scheduling. Automate all you can. I think we all know that by now. The more that we can take out human interaction with our scheduling, the more efficient we become. We are now allowing that individual to be productive in what we need them to be productive, not just running around programming thermostats. And I know, and I talk to facilities, that that's what they do. They get a schedule of events and they have somebody go to each thermostat for the week and program that thermostat. Now, I'm glad that they're programming it, but that's eating up time, and that time you're not going to get back. Whereas if we can input a control system, a Wi-Fi, something that can integrate with scheduling, the time that is not spent by that individual, that's part of that return on investment. So don't forget to calculate that. It's not just the energy savings, it's the personnel costs that you're saving. It's the fact that we can get more things done because we're not having to go and send somebody to do that stuff. Okay? And don't go to your comfort set point unless you have a confirmed event. A lot of times we do general settings. Well, we typically have this event on Wednesday. We typically have this stuff on Thursday, so on and so forth. Sunday is about the only day that we do kind of bulk or batch scheduling, because we know we're busy all day Sunday for certain hours of the day. But other than that, you should not need to go, or should not go to your comfort set point unless you have a confirmed event. If we can get that and train our folks and get our culture to accept, always get something on the calendar, then that means we're much more efficient and we're saving money because we're not cooling spaces we don't need to. And it also means if we can teach them to take it off the calendar, if we've got some sort of automated scheduling, then it's automatically going to take the event out of the system as well. And it should have some mobile access component. That's always ideal. You shouldn't have to just be at your desktop to access the system and do things. Now, like every app, it is not necessarily going to have full functionality of a desktop view, but you should have some ability to manipulate the system through an app. Trending and graphs. Data collection is huge when we start talking about HVAC control systems. The data that is collected, if you are cognizant on learning what it's representing and what it's seeing, you can use it to help diagnose and even limit service calls and look at your equipment and save even more money down the road. So for example, a couple examples here that we've seen and we've actually used the data to prove. A unit that was showing a persistent loss and regain of power when it was supposed to be running. We were seeing it in the thermostat. The thermostat wasn't working, then it was on, then it wasn't, then it was on. The thermostat gets power from the unit. When we went up to that unit, when the church went up to that unit to look at it, what they found was a clogged drain, which caused the water to back up in the drain pan, and they had a water flow sensor in the drain pan. So it wasn't a bad thermostat, it wasn't a bad unit. It was simply a unit that had a problem, and we were able to diagnose it just by looking at the graph. The call was, how come your thermostat's not working? The answer was, it's because your unit needs attention. Unclogged the drain, unit ran fine. We also see sometimes a unit that can get really, really close to set point, maybe 2 to 3 degrees off of it, but never quite get there no matter what. No matter if it's early morning, late afternoon, if the doors are open, if the doors are shut, it doesn't matter. If we see that, if we start seeing that trend, especially if previous to that it was achieving set point, a lot of times that's a good indication that we need to check the refrigerant level. Low refrigerant, it'll still provide some cooling, but it's just not going to be as efficient and as effective, and that's how we can tell, and we can look at that graph. We can also tell a lot of times when people manipulate the set points, change the stuff. So when somebody says, I don't know who changed it, we may not know who changed it, but we know when they did it, and we can tell them that's why it's not as comfortable as we were hoping it would be. And then supply air sensor. Many of our Wi-Fi stats, many of the Wi-Fi stats that are available will have at least one sensor input available. If they do, a great one to consider, and many don't, but I do want to stress it's a great sensor to consider, is this supply air sensor. Many times you just drill a hole just past the blower and the coil in the duct, and you stick in a probe sensor, seal it up, and run it back to that thermostat. And what that does is now we can tell what the leaving air temperature is at the point that it's supposed to be and achieve the greatest cooling or heating level. So typically, if we've got thermostat set at 70 degrees, we're looking for 54 degree air coming out of there. Looking about a 25 to 30 degree differential somewhere in there. If we're not seeing that, then we know it's that perhaps we need to look at the unit if it's not achieving that differential that we're expecting. If it is achieving that, but the room still feels hot, now we know we need to look at something else. But it is a often underutilized option for facilities, is being able to look at the supply air versus the room air. Because the temperature, when we put these thermostats in these big rooms, they're not always in the most ideal spot, and it's not always giving us the language or the information that we need. So check that supply air sensor. It's a great way. Consider it down the road. So when we talk about a return on investment, conservatively 10 to 20% payback just on energy savings when you put a better control system in. That's conservative. Realistically, if you really pay attention to how you schedule it, doing that 3 levels of scheduling, make sure your setbacks are the way they're supposed to be, that percentage jumps way up. But conservatively, just by taking control of and limiting how often the unit is left running when it doesn't need to be, or being able to shut it off if you do find it from a app, not having to walk to it, that's going to save you 10 to 20%. We start factoring in time saving from dealing with stuff, scheduling, things like that. Now we're getting any more money back. So again, the schedules you set and how well we can remove the human influence on the system. So again, it's doing that lockout. It's limiting what people can do to affect it and impact it. And then training them to put in when the events are actually occurring and taking them off the calendar when they don't. And finally, some necessary knowledge. When you're considering controls, you're considering what you want to do, make sure you know what you have. It sounds very simple, simplistic statement. Gee, make sure you know what you have, but it's important. To get the best information back as to what's possible, we have to know what we're starting with. So knowing what type of units you have, their age, the number of them, that's very important. And we're talking not just, I've got X number of direct exchange units and this, that, model and serial numbers, so that we can dive deeper if we need to into control diagrams and wiring diagrams. Some systems have factory set or factory installed logic boards. And for some of those systems, it's very difficult to retrofit a Wi-Fi or a different thermostat because it's designed to work with sensor inputs, not necessarily a stat. And since it's got that internal logic, if you put a regular stat on it, it's not going to operate efficiently because it doesn't get the inputs it needs for the internal logic, okay? If it's an existing control system, you got to know what language it speaks, and how do we connect into it, and what it will take to connect into it. Many times, softwares and equipment can talk with each other, but it takes an additional piece of something, an adapter or a different router, something. And it's important to be able to know all that information up ahead of time as we're figuring out the pricing, so that we're not continually hitting different pieces of equipment. And we need to know how you want it installed. It's different if you've got the ability to put equipment on an internal network or on a computer on site, or if you're trying to do it all cloud-based or server-based, which many times we can do that, but sometimes we've got to have some additional workarounds to make that happen. And will your IT infrastructure support it? So Wi-Fi is a great one. If you're using a Wi-Fi stat, you've got to have good Wi-Fi coverage throughout your facility. Great, easy way to test it, take your phone around. Do you get Wi-Fi coverage, good signal from your router or from your radio everywhere you've got a thermostat? If you get spotty coverage, your thermostat will be impacted by that. And finally, the biggest thing necessary is who are you going to train and make responsible for it? As you start getting past these simple thermostats, there is training that is recommended, that is beneficial, and it's very technical and can get technical. The more that we study it, the more that we dive into it, the more that we realize there's more to learn. So are you going to give somebody the time and opportunity to train and be trained on the system to be able to maintain it efficiently and effectively? Obviously, we recommend that you do, but make sure that you've thought that through. Everyone, that is our overview and our introduction to HVAC control systems. At this time, do we have any questions? Questions about anything on controls or anything that we've talked about? Any additional, anything I need to go in deeper regarding? Feel free again to submit them there via the question pane or on the control panel there. Happy to answer them. Next month, I do want to point out October, we are having a special guest, Deborah Ike, who's going to talk to us about event planning and effective and efficient event planning. She's featured on our resources page on CFMS, and it's a great opportunity to, as we look ahead, especially to the holiday season, as to what it takes to be effective and efficient with our event planning. Following that, we are going to have Tim Kuhl in November on life cycle and planning ahead, planning for the inevitable. And in December, we're going to have a special guest. We're meeting with a gentleman from the Environmental Protection Agency regarding Energy Star. So we will look forward and hope to see you there. First question that's been submitted is, can they contact us here at Cool Solutions Group if they've got someone that is looking and you're looking at integrating with us, which, hey, we always like it when we try to integrate. We appreciate that. The answer is yes. We're happy to take a look and do what we can. Understand that we'll do the research, we'll figure out, and we'll give you our suggestions, and we're certainly able to talk to a contractor about what our system does and how we integrate to make sure that we've got the right solution that'll work, and we are happy to do that for you. Our goal is to never get you something or put something or suggest something that in the long term isn't the best choice for you. And quite frankly, sometimes integrating with us is not the right choice depending on the type and age and types of the systems. If that's the case, we'll let you know. If we want it to be effective and efficient. Okay, next question is, we've got our hardware and software controllers are different. How do we upgrade to a more user-friendly system for managing HVAC? It's an older system. It's a great question. It starts with determining, is anything salvageable? Do you want anything left? And if the answer is no, then it's simple of, okay, what does it take then to take control of our existing equipment with something either off the shelf, or do we need to call somebody in and get a more robust system? With the advance, with the things like InTouch, Pelican, and several of these other controller companies are doing, a simple control system will handle quite a bit of what we're doing. And many of these companies, I talk with these reps quite a bit, they tell us if we give them the needs of a facility, what type of stuff they need, then they will have their engineering team look at it and see what solutions they have to make that work. So if you don't need it, okay, let's see about if we're not going to use it, that'd be the first step. Can we upgrade it? Do we have to save anything? Now, if we have to save something, then we just have to say, okay, what language does it speak and what will speak that language? Is there a way around it? Many of these older systems, though, do not and are not very friendly when it comes to integrating with additional or newer stuff. Again, we start talking about computers, we start talking about IT, and we're talking about stuff that's not always backwards compatible. So if we've done there and we've decided to move it up and we think, okay, if a simple system will work, then I always encourage people to do that. The most simple way to go is, can we get by with just wiring standard 24-volt Wi-Fi type thermostats into all our equipment and making it work that way? If we can do that, let's do that. That's the simplest way to start. Then we can go to the more robust, simple solutions. If we've got to go to a JACE, that's when, honestly, me as a facility specialist says, you need to find a controls company near you that can answer these and work these, because you need to find the company that's going to not only recommend the right solution, but be able to support you from start to finish and in perpetuity as you have that system in there. Questions on, keep in mind the slide deck and the recording of this webinar will be available later on CFMS resources. Give me a couple days to get that modified and uploaded. We'll have that, and if you have some additional questions, remember, you can always reach us at cfms@coolsolutionsgroup.com. Many of you know how to reach me direct as well through my email address. I'm happy to answer that as well. What other questions do I have, or does anybody have, or do I need to go any further on any of those questions I've already answered? All right. I am not seeing any hands raised, or if somebody's typing, they can raise their hand, and so I know not to go. But if not, I just want to say I really appreciate your time. I appreciate you folks coming in and spending this almost hour with us. Tomorrow you'll get an an email with a survey on it. If you have the opportunity, I would appreciate you filling out the survey, letting us know what types of webinars we need to do, what other topics, who we need to get. Again, these are designed for getting you and getting the information to you that you need. And so we really want to know, we want to hear from you about that. So again, this has been Church Facility Management Solutions, HVAC Control Systems. This is Nathan Parr, again, Cool Solutions Group. If you have any further questions or need additional information, we're available, cfms@coolsolutionsgroup.com. Appreciate your time. I pray that you have a blessed rest of the week. And for those of us that are on the session that are on the East Coast, special prayers go out to all of our folks and all of our churches and folks that are on the East Coast as the storm comes in. Just if you think about it, please keep them in your prayers. Thank you all and have a great rest of the week.